Good evening, children. Welcome back to one more session of mathematics. In the last class, we completed the applications of trigonometry with this long as type questions, which are statementical problems. Today, we'll see the new chapter, one of the most important and also very easiest from the paper 2. The last but one chapter, that is probability. In the probability itself, probably. What? Probably. Probably means slowly. Nammadiga. Probably. The rain will come. Maybe. Probably. Chances. What? Chances. The probability, one of the chapter, totally depends upon the events. Totally depends upon the events. Suppose one of the match is going on. Who will win? Cannot decide. Comes under the part of probability. Probably the chances are there to win one of the party. Let us take that India and Australia. Who will win? Maximum the people will say that Australia. Yes? Nowadays the India team also excellent. Good. Fine. So what they will say? Probably chances. Chances will be there. Chances will be there. So Mr. Perry Simon Laplace developed this probability, one of the chapter. Just here, few are there, that's it in 10th standard. Very few. Some huge subject. Actually, if you want to go with a little deep, it is a heavy, more large chapter that is. It's given very little in 10th standard level. In IIT, it's a very deepest subject that is, and also excellent subject that is. Fine. The total chapter depends upon only one formula. It's a great thing that is to say. Only one. Whatever the problem, if you want to solve, it depends upon only one formula. That is probability of event equal to total number of favorable outcomes by total number of outcomes. Number of favorable outcomes by total number of outcomes. This is only one formula we have. What is favorable outcomes? Sometimes, let us go with one toss. One coin will be there. We'll going to toss. Whenever you will toss that, you'll say that tails, suppose. At that time, the tails is your favorite. At that time, spontaneously you said no, tails. All the time you will never go with tails. Yes? Sometimes maybe you'll say heads. At that time, your favorable outcome is heads. So that is called favorable. The spontaneous when it's going on. What you want particularly, that is called favorable. It's not tails is favorable, it's not heads is favorable. At that particular time, what you will say, and that is called favorable outcome. That is called favorable outcome. Understand? So let us go with now the probabilities of events. Okay. Before that, who is a developer? Perry Simon Laplace. Perry Simon Laplace was in 17th century. 1749 he was born, and he is no more at 1827. 1749 to 1827. 78 years his lifespan. 78 years. 78. Probability. Eric, Simon, Laplace, 1747 to 49 to 1827. His lifespan. 16th or 17th century, we can say that. Probability. Only one. Number of favorable outcomes by total number of outcomes. Only the one part. Probability. Probably. Slowly. Chances will be there. Slowly. Maybe this called, that is, it depends upon the event. It depends upon the main event. Let us go with one of the event, that is, first one is we'll take coin only. Let us take one coin. How many chances will be there in a coin? There will be two chances. There will be two. One is head, one is tail. One is head, one is tail. The total number of outcomes are 2. So if you want to go with the heads, what will be the probability? Whenever you will going to toss one coin, it will give either head or tail. So how many times? Only one head we will call, that is 1 by 2. One head by 2. Total number of outcomes. Total number of outcomes. Probability of the particular event, that is equal to number of favorable outcomes by total number of outcomes. Number of favorable outcomes is nothing but what? Suppose your favorite is head, one time only head will be there. So 1 by 2. 1 by 2. So like this, let us see here. Probability. And also one more thing, that is probability the result within the 0, not less than 0, and it never cross 1, more than 1. Maybe the 0 or 1 in between. In between. In a probability, whenever you will toss, suppose, can you see that head and tail? Can you say that head and tail? No, we cannot. Such type of chances we will call, that is impossible event. Such type of chances called impossible, which is called 0. The probability is called 0. The probability result will be 0, which is impossible event. Which is impossible event called 0. Whenever the result will come 0, such chances we'll call, that is impossible event. Impossible. It is never possible whenever you will going to toss head and a tail. No. It is called impossible event. So if you want, suppose only one team is there, 100% the chances are there it will win. Directly we will say that is yes. Only one chances will be there. Suppose only one candidate is there. If you want to run away, obviously the same person will come to win a first standard, first place. That is called sure event. Okay, let us take here coin itself. We will take, let us take again coin. Whenever you will toss that, you will get compulsorily the result. Okay, head or tail, that is secondary. Surely you will get compulsory. You never get head and tail, na? Maximum. So it's called, that is sure event. Sure event is nothing but 1. Sure event is nothing but 1. Once maybe it's tails, maybe heads. So 2 times. So sum of the all events also called 1. Sum of the all events is 1. Remember. And the probability within the 0 or 1 or in between. It never cross more than 1. It never less than 0. It never be negative indirectly. It never be negative. Either 0 or 1 or 0 0.1, 0 0.2, 0 up to 9, 0 0.9. It never be 1 point something. It never. Even 1.01 also you won't get in probability. Remember that is. It never cross 1. It never below 0. The within the probability that is 0 and 1 within or 0 and 1. Maybe 0, maybe 1 or in between. Fine. Let us go with one example. With that, the same example will go with the chances that is coin. Let us go with the coin. Here, okay, first we'll write the probability. Probability is equal to number of favorable outcome. Number of favorable outcomes by total number of outcomes. P is equal to probability is equal to probability of particular event is equal to number of favorable outcomes by total number of outcomes. Total number of outcomes. This is the formula. Let us go with one coin. One coin. So in this you will get a head either or tail. You never get both H and T. Either you will get head or tail you will get. So let us take here. Only one coin is there. So here either head you will get, tail you will get. So probability of head. What will be the result? Head is nothing. At this time, the head is favorable because you are asking the question of head. Which one you will raise, that is only called favorable. That is only called favorable. Which you will raise the result, which you will raise the question, that is only called favorable item. That is only called favorable the thing at that time. Now at this present, at this time, head is nothing but here. This is the favorable. Since we know the formula, total number of favorable, total how many will be there? How many? Only one. One outcome you can see. Only one see. Either it is height or it is tail. How many heads are there? Only one. Total number of outcomes are this is 1 and 2. 1 and this is 2. So same like that. Probability of tails. Let us go with the tails. How many tails are there in a one coin? Obviously one. Obviously one. Probability of tails. That is nothing but one. How many total number of outcomes? Again, total number of outcomes. How many? 2. It's nothing but 1 by 2. The result of 1 by 2 in decimal 0.5. Is it crossed here 1? Is it less than 0? No. Within the 0 and 1. All the time the probability result within the 0 and 1 or 0 or 1. So the result of this, and one more thing, the thing is sum of the all events means how many events we have? 2 events. One is head, one is tail. Sum of these 2 events is all the time 1. Sum of the all events, if you will add, the result you will get 1. How? See, add these 2. Add these 2. Just example. 1 by 2 plus 1 by 2. What is the LCM now? 2 is the LCM. How many times going? It is going only 1. 1 ones are 1. 1 ones are 1. 1 plus 1 is 2. 2 by 2, that is the result. Sum of all the events. Sum of all the chances. It will be only 1. It is only 1. Got it? Okay. Let us go with one more example. Now we'll go with the 2 coins. We'll go with the 2 coins. Suppose if you have here the 2 coins, this is a Let us take this is the first coin and this is the second coin. Coin 1, coin 2. C1, C2. Okay, coins. Let us go with this. So, whenever here you have to take like this. In a two hands you have to take. If you take the two coins, whenever you're going to toss, what the chances, how many chances you can see? You can see like this. Maybe both the coins are, the chances are there to get heads. Whenever you will toss, randomly, whenever you will toss like this, the chances will be there, head, yes, second one also many chances will come head. One of the chances is both are head. Second chance, if you will do again, maybe first coin you will get a head, the second coin you can see chances, you can see tails. In the second place, whenever you will going to toss, randomly, just blindly take the two coins and just give the toss. Maybe the chances head and head. Next time again, one more time, if you will take, maybe the chances will be there, head, sorry, tail, and one more is head. Maybe the first coin, whenever you will toss, this one you will get, the first one you will get tail, and the second one you can see head. The chances are there. You will get like that even the chances. And once again, if you will toss, once again, you can see that both are tails. Chances are there. This is only called chances. This is only called chances. Whenever you are going to toss the two coins, you can see that maybe the chances both are heads. Maybe the chances one is head, the other is tail. The third time you can see one is tail, the other is head, and the both are tails. You can see the both are tails. Okay, so the chances are there. So nearly 4 chances. When the two coins will be there, you can see the 4 chances. We have a formula even we have a formula. The formula is, when suppose here only one coin will be there, you can see the formula is 2 power n. 2 power n is nothing but here 2 power how many? How many? 1. How many coins are there? 1. N is nothing but a number of coins. N is nothing but number of coins. 2 power 1 is nothing but 2. 2 power 1 is nothing but 2. Means 2 chances. 2 chances. One is head, one is tail. Just to be completed before I erased this. So same like that. Suppose 2 coins are there. 2 coins are there. What is the formula? 2 power n. N is nothing but what here? N is nothing but 2 power 2. Na? 2 coins. Na? So 2 square how much? See, 4. 2 square. 4 chances. We can, with the help of this one, we can find it like this. Suppose here 3 coins will be there. 2 power 3. Nothing but 2 into 2 into 2. That is 8 chances will be there. 8. Shall we? We'll go with the 3 coins. We'll go with the 3 coins. Maybe the chances in the first chance, let us take, you should have to get how many chances? 8. Whether you will get or not, we'll see. Okay? We'll see. Just say example. H. We are not went with the problem. This is the process. The problem is there. We'll see. Yes, maybe the chances here 3 heads. Maybe the chances are 3 heads. When the 3 coins you will toss at a time like this, at a time 3. The one more person will be there. You can, otherwise you can hold the 2 coins in one hand, in the other one like this also you can. Yes, at that time you can see the varieties. That is all the 3 coins you can see. Suppose sometimes maybe the chances is only the chapter here. Probability. That is H. All the 3 are H. The second chance, in the second chance, maybe you can see the first two coins are heads, the other one you can see tail. The first two coins you can see head, the other one you can see tail. Understand? The other one you can see the tail. The third time, if you will toss, maybe here first one and the third coin will get, suppose both are heads. The second one coin you can see the tail. And one more time, if you randomly if you will toss, and you can see like this. One is tail, the first one, the other two are heads. The other two are heads. Everything Mr. Perry Simon Laplace developed the system. Developed the system. Both all are heads. Both are heads. One is tail. The second one is tail. The other two is heads. The first one is tail. The other two is heads. How many chances you got? 8, 4. But what is the result? 8 chances. Yes. Reversely write down. Suppose T H H na. Write down here. H and T T. Simple. Just reciprocal do that one. Opposite write down. T H H na. H T T you will get. That is one of the chances. Means first coin you can see head. The second coin you can see tail. The third coin you can see tail. See, you can't see that the same. All the chances will be unique. All the chances will be unique, different. It never be much. It never be same. Okay? And here H T T. And see, this is complicated. Now comes to this one. H T H is there. Means T H T. H T H na. T H H. And this is complete. Now here H H T na. T T H you can see. T T H you can see. T T H. And finally all the H is there na. You can see T T T. Actually I have to write here, but I hope that you can't see. That's what I'm writing on top. T T T, the last one. H na. T T T. Now counting how many chances? 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. 8 chances. 8 chances will be. 8 chances. Whenever you will write, suppose 4, the reciprocals of 4, the opposite of the 4 chances, if you will write, the other 4 you will get. Adding up that both, you will get 8. If the 4 coins will be there, 2 power 4c, 4 coins will be there, 2 power 4, that is 1, 2, 3, 4, that is 16. 2 2s are 4, 4 2s are 8, 8 2s are 16, 8 2s are 16, 8 2s are 16. So if 4 coins will be there, you can see the 16 chances. But maximum to you, I hope that 2 only it is more than. Sometimes in a bit he will give 3 coins also. Sometimes, very rarely he will give. Now come to the question part. Suppose here 3 coins are there. 3 coins are there. On these 3 coins, we'll go with some points, some questions. Sorry. Okay. So how many? Totally 8 are there. Fine. Right. Now the question is, which I am raising the question, that is the favorable thing at now. Favorable chances at present. What is your favorite? You can't. Whatever the question you will raise, that is only called favorable item. That is only called favorable chances. That is only called favorable outcome. Whichever you will raise the question. Let us see here. The question will be like this. What is the problem? If the 3 coins will be there, if the 3 coins will be there, if the 3 coins will be there, what is the probability What is the probability of getting the only heads in a 3 coins? What is the probability of getting the only heads in the 3 coins? Understand here the question? What is the probability? What is the probability of getting the only heads in 3 coins? Only heads. You are right. Only heads. Probability of result. Only heads of 3 coins. Of 3 coins. What is the formula? This is the formula. Number of favorable outcomes by total number of outcomes. Number of favorable outcomes by total number of outcomes. Yes, only heads. How many are there? See, H, T, T, T. It's not there. H. Yes, only heads is there now. Here it is there. Only head. Is there any tail? No. One it is there. Next, T. Here it is there. T. What is the question? Only heads. Probability of getting the result only heads of 2 coins. 3 coins. Only heads of 3 coins. That is only H. One time it is there. Here one of the tail is there. In this case, one of the tail is there. In this case also one of the tail is there. Here 2 tails are there. Here also tails there. Here also tails there. In the first part also tails there. Only at one place, only at this place, only this one, only heads. Probability of getting the only heads of 3 coins. Here if you want only heads of 3 coins. That is formula you have to write. And how many? Only one time. Total number of outcomes how many? Total number of outcomes how many? Already we know that is how many? 8 outcomes. 1, 2, 3, 4, 5, 6, 7. Total number of outcomes are 8, but in that only heads is 1 time you have. Not 3. For your kind information, you should not count like this. Should not count like this. 1 by 8. 1 by 8. It's fine. Let us go with one more question. What is the probability of getting the tails of 3 coins? Tails of 3 coins. Tails. There is a difference between these 2 questions. Only heads. Here, tail is there. Tail. Not only tail. Tail. That means, in this first case, tail is there or not? Yes, 1 chance. In the second case, all the 3 are heads. There is a no tail. We cannot count that one. In the third case, yes, one of the tail is there. Probability of tails he is asking. Probability of tails he is asking. He is not asking 1 tail, 2 tails, all the 3 tails, or only tails. Tail. In this case, whether the tail is there or not, that's it. So 1 tail is there. So how many chances? 1. Here it is there 1. This is 2. See, here also it is there tail. 3. Here also it is there tail. Here also it is there tails. Here also it is there tail. See, 1, 2. And here also you can see the tail. 1, 2, 3, 4, 5, 6, 7. Except this all the heads. Only heads. How many? 1, 2, 3, 4, 5. Whether in this case, whether in this chance, the T is there or not, the tail is there or not. That's it. Yes, it is there. 1 tail, if it will be there, yes, tail will be there. How many chances you got it? Totally 7. Out of how many? 8. Total number of outcomes, how many? 8. Number of favorable outcomes, how many? Favorable are 7. At this time, your favorable outcome is probability of getting the tail of 3 coins. Only heads, a lot of differences. One more, let us go with the example. Probability of getting the 2 tails. 2 tails of 3 coins. 2 tails. 2 tails we have to do. In this chances, 2 tails of 3 coins. 2 tails were, see, 1, 2, 3. Shall we count this one? 2 tails is asking. 2 tails are more than 2 tails. That is the difference here. He will give 2 tails. Whether it is 2 tails are there, here 3 tails are there. He will ask the question, 2 tails and more than 2 tails. 2 tails and more than 2 tails here. And also sometimes he will give only two tails. A lot of difference will be there. Don't be confused. Probability of getting the only 2 tails means you have to count like this. See, 2 tails are there now here. Here it is there. 2 tails are there. And here it is there. 2 tails are there. And here it is there. 2 tails are there. Here tail, 2 tails. In this case, 2 tails is there. 1. In this here also it is there 2 tails. Here also it is there 2 tails. In this also you got it 2 tails. 2 tails or more than 2 tails. We want the 2 tails. Why we have to take this one? He did not ask here question. He did not highlight the word only 2 tails. Only 2 tails means these 3 we have to take. We should not take this one because these are the 3 tails left. 3 tails. Only 2 tails means these 2. He did not mention anything. He mentioned only probability of getting 2 tails of 3 coins. 2 tails of 3 coins. That is 1, 2, 3, 4. 4 by total how many? 8. Nothing but 4 ones are 4 twos are. No. 1 by 4 ones are 4 twos are. 1 by 2. 1 by 2. The question is whether either it is only 2 tails. That is important. Sometimes he will give 2 and more than 2 tails. You will not be confused. Don't confuse at that time. Directly you will get okay, fine. Here is asking 2 tails. 2 tails are there. Why? Whether the third one it is a tail or a head, it doesn't matter. Only the thing is the 2 tails are there or not. Yes. If it is a more than, what will be there? You want to go Hyderabad, whether it will go by Karimnagar or Siddipet, that doesn't matter. It will come, so okay, maybe the way is from Godavari Kani you have to reach up to Hyderabad, that's it. Maybe the Karimnagar will come, is it not? Peddapalli, everything, that is not a matter. Our target is whether you are reaching the Hyderabad or not, that is only the thing is here. Fine? Yes. 1, 2, 3, and 4. 4 by 8. Like this. Suppose, what is the probability of getting the only tail of one tail of 3 coins? One tail. Probability of getting the only one tail of 3 coins. Okay. One tail of 3 coins. Probability of getting only one tail of 3 coins. One tail. In the 3 coins, only one tail. See, here it is the one tail. Yes, one it is the here. All are tail. Only one is only one. Condition is that one. Only one tail. Here also only one tail. Here also only one tail. 3 times it is there. Here it is both are 2 tails. 2 tails are the 2 tails. Only how many? 3 chances are there out of 8. Out of 8. Out of 8. Here the 3. Only the 3 chances are there. Only the 3 chances are there. Probability of getting only one tail of 3 coins. One tail of 3. That is 3 by 8. So same like that. You can do that whatever, but step by step. You have to write here. What you have to write here? Number of favorable outcomes of 3 coins is equal to 3. You have to write the steps. The steps is here. What is the question? That is only the first one. Number of favorable outcomes of 3 coins. Otherwise, you can highlight number of favorable outcomes of only one tail of 3 coins. Only one tail of 3 coins is equal to 3. Is equal to 3. Total number of outcomes is equal to 8. Formula you have to mention. Probability of event is equal to number of favorable outcomes by total number of outcomes. Then after 3 by 8, only 4 steps. What is the first step? Number of favorable outcomes of only tails of 3 coins is equal to 3. Total number of outcomes is equal to 8. Next formula. Then after 3 by 8. This is the way to solve the problem. This is the way to solve the problem. Okay, simple. This is on one event. We have a maximum 3 events or 4 events we have all together in our textbook. One of that is coins is completed. We'll go with the deck of cards, playing cards, you know, the playing cards. I hope maximum people know. We'll go with one more event, that is playing cards. And the dice, nowadays in a lockdown period, I hope that every people, even the parent also went with the dice. Astachamma. Otherwise, what will say that dice, you know, that 6 dots will be there, 1 dot, 2 dot, 3 dots, 4 dots, 5 dots, and 6 dots. And the thing, and one more thing is the picking one of the item from the box, whatever. So these are the more rest of the 3 events are there. We'll go with the other session. We'll go with the one more session. Okay. And till that one question only I will give as homework. Write down the question. Make it. Otherwise on screen I will write. What is the probability? What is the probability of getting? What is the probability of getting the head of 2 coins? Once again, what is the probability of getting the head of 2 coins? Already I done. Head of 2 coins. Have to go with very carefully. Whether it is a head, only head, or what, I don't know. Just do it and upload to my number. It's clear? What is the probability of getting the head of 2 coins? Head of 2 coins. Shall I go with one more question? Yes, fine. Let's go with one more. What is the probability? What is the probability of getting the? What is the probability of getting the 4 heads? 4 heads of 3 coins. Read the question very carefully. Write down that in your paper. Take the shot, take the pic, and upload that one. The 2 questions as your homework. Take the screenshot of this one. If you'll have more doubts, once again watch the today's YouTube class. Then you can clarify. I hope that you will get more clarification on this event, which is we deal with 1 coin, 2 coins, and 3 coins. I hope you people understand excellently. Thank you.